Alright, let's work through this problem carefully from the beginning, because the shaded region may look complicated at first, but there is a very clean idea hiding underneath it. We have three identical circles arranged inside a rectangle, XYZ. The two circles at the top are side by side. They touch each other, and each one is tangent to the appropriate sides of the rectangle. The third circle sits underneath them, touching both of the upper circles and also touching the bottom side of the rectangle. We are told that the area of each circle is 4 pi square units, and our goal is to find the exact area of the shaded region inside the rectangle, but outside all three circles. So, before we start calculating individual lengths, let's make our main observation. The shaded region is simply whatever remains after we remove the three circles from the rectangle. In other words, the shaded area equals the area of the rectangle minus the total area of the three circles. We already know the area of each circle, so the main challenge is finding the dimensions of the rectangle. Let's begin with the radius of each circle. Since the circles are identical, they all have the same radius. Let's call that radius r. Now recall the standard formula for the area of a circle. The area equals pi multiplied by r squared. We are told that the area is 4 pi, so let's substitute that directly into the formula. We get 4 pi equals pi multiplied by r squared. Now look carefully at both sides. There is a factor of pi on the left and another factor of pi on the right. Since pi is non-zero, we can divide both sides by pi. That leaves us with 4 equals r squared. Now we need r itself, not r squared. So we take the positive square root of both sides, because a radius represents a length and therefore must be positive. That gives us r equals 2 units. So we have our first important result. The radius of every circle is 2 units. And once we know the radius, we immediately know the diameter. The diameter is twice the radius, so the diameter is 2 multiplied by 2, which gives us 4 units. Now let's use that to find the width of the rectangle. Look at the two circles positioned across the top. Each circle has a diameter of 4 units. The first circle stretches across 4 units, and the second circle stretches across another 4 units. Since the two circles touch each other, there is no gap between them. Therefore, the entire horizontal width of the rectangle is 4 plus 4, which equals 8 units. So the width of rectangle WXYZ is 8 units. Now we need to determine its height, and this is where the geometry becomes interesting. Let's focus on the centers of the three circles. Call the centers J, K, and L, where J and K are the centers of the two upper circles, and L is the center of the lower circle. Because the two upper circles touch each other, the distance between their centers is equal to the sum of their radii. Each radius is 2, so JK equals 2 plus 2, which is 4 units. Now, the lower circle touches each of the upper circles. That means the distance from the center of the lower circle to the center of either upper circle is also the sum of 2 radii. Therefore, JL equals 4 units, and KL also equals 4 units. So notice what we have here. JK is 4, JL is 4, and KL is 4. That means the three centers form an equilateral triangle with side length 4 units. This observation is extremely useful because we can now determine the vertical separation between the upper centers and the lower center. Imagine drawing a perpendicular from L down to the midpoint of JK. In an equilateral triangle, that perpendicular divides the base into 2 equal parts. Since JK is 4 units, each half is 2 units. Now we have a right triangle. One leg is 2 units, the other leg is the vertical distance that we want, and the hypotenuse is 4 units. Let's call that vertical distance h. We can now use the Pythagorean theorem. Remember, the Pythagorean theorem says that in a right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. So we have 2 squared plus h squared equals 4 squared. 2 squared is 4, and 4 squared is 16. Therefore, 4 plus h squared equals 16. Subtract 4 from both sides, and we get h squared equals 12. Now take the positive square root of both sides. The square root of 12 can be simplified because 12 is 4 multiplied by 3. The square root of 4 is 2, so the square root of 12 becomes 2 multiplied by the square root of 3. Therefore, h equals 2 square root of 3 units. So the vertical distance between the centers of an upper circle and the lower circle is 2 square root of 3 units. Now, let's use this to find the entire height of the rectangle. Start at the top of the rectangle and move downward to the center of one of the upper circles. Because the upper circle is tangent to the top side, that distance is exactly 1 radius, which is 2 units. Next, move from the upper circle center down to the lower circle center. We just calculated that distance as 2 square root of 3 units. Finally, move from the lower circle center down to the bottom of the rectangle. Because the lower circle is tangent to the bottom side, that distance is again 1 radius, or 2 units. Therefore, the total height of the rectangle is 2 plus 2 square root of 3 plus 2. Combining the two ordinary numbers, 2 plus 2 gives 4, so the height is 4 plus 2 square root of 3 units. At this point, we know both dimensions of the rectangle. The width is 8 units, and the height is 4 plus 2 square root of 3 units. Now we can calculate the area of the rectangle. Remember, the area of a rectangle is length multiplied by width. So the rectangle area is 8 multiplied by the quantity 4 plus 2 square root of 3. Now distribute the 8 across both terms inside the parentheses. 8 multiplied by 4 gives 32, and 8 multiplied by 2 square root of 3 gives 16 square root of 3. Therefore, the area of rectangle WXYZ is 32 plus 16 square root of 3 square units. Now let's find the total area occupied by the 3 circles. We already know the area of one circle is 4 pi square units. Since there are 3 identical circles, we multiply 4 pi by 3. That gives 12 pi square units for the combined area of all 3 circles. Now, we are finally ready to calculate the shaded region. Remember our original observation. Shaded area equals rectangle area minus the area occupied by all 3 circles. We found the rectangle area to be 32 plus 16 square root of 3, And we found the total circle area to be 12 pi. So substitute those values into our equation. The shaded area equals 32 plus 16 square root of 3 minus 12 pi square units. And that is our exact answer.